In the last video, we talked about shapes of distributions, and I talked about the 3 different shapes, and then you're like, what? There's a 4th one there. Okay, so there's kind of a 4th one, but it's not really a shape, right? It's something like this. This is like if you spun a spinner or if you rolled a die. And if you spin a spinner and all of them have an equal probability of getting landed on, then eventually, if you spin it enough times, you're going to have very similar results through all of them, right? There's not going to be lots and lots of ones and very few eights, or lots and lots of eights and very few ones, or lots and lots of fours and very few of the other. If I roll a die, I'm going to have the same probability of getting 1 as I have getting a 6. So this is going to be a distribution that really has no shape. It doesn't have, it might be called uniform because it's just kind of all across the board about the same. And this is skewed right. This is skewed left, remember, because we've got the big chunk of things over here, and then we've got that long tail to the left. And this one is a symmetric, and there's a very special symmetric curve called the normal curve, and we'll talk a lot more about it tomorrow. But the normal curve is a special type of symmetric curve that all of the data falls within a certain area of the middle. But a symmetric curve, basically, you could cut it in half and you could fold it and it would be about the same on either side. And if you look at this, it's not exactly the same, right? Like I could look at this and say, these are not the exact same. But that's the weird thing about statistics is it's not exact, right? So even though there's not exactly the same on both sides, if it's really, really close, then it basically is a symmetric curve.